Good day. We're going to try to make an electrochemical cell. Here I have a copper electrode, and here I have a zinc electrode, and so I've got to add solutions. So I'm going to add some zinc sulfate here. And this, the copper half cell, I'm going to add some copper 2 sulfate. Oh, I better put a little more of the zinc solution here. Okay. Now, I've got wires to a voltmeter, but nothing's happening because I haven't connected 2 half cells. So I have to have my electrolyte. So I'm going to pour in electrolyte here, and this is cleverly called a U-tube, and when we flip it over, it won't look so much like a U-tube. I guess it'll look like a little N-tube. This is just some glass wool, and inside the U-tube I put a solution to act as a salt bridge. So I got to do this carefully. I got to have these things close together so I can connect them together, and then we have to see that we made. Let me hook up the voltmeter. Well, that sounded promising. And so if we zoom in on the voltmeter, you can now see the needle, and we are making in the order of somewhere around 0.65 volts. I didn't do this under standard conditions. But what we've got is we've got a copper half cell here, so we have copper and copper ions, and we have zinc and zinc ions in solution. And this zinc electrode is going to get lighter because the zinc is going to be oxidized into zinc ions, and here copper is going to be reduced. So we're going to actually add copper to our copper electrode. And electrons, it turns out, always go anode to cathode. So they go from the zinc here, they go through the meter, create a voltage, and then they come here. And electrons are continually supplied to the cathode that copper ions pick up as they plate on. So that's a half cell in action.